Problem 12.21. So suppose we have a random sample of size alpha from its exponential distribution with theta as a parameter. Then we want to test the null hypothesis theta equals to 0 versus the alternative hypothesis that theta is not equal to 0. We want to find the expression for the likelihood ratio test. The second part is that we use the result in A to show that the critical region can be written as something like this simple. Okay, so now first part. The first part we want to find the likelihood ratio test. Remember that it's going to be okay. That we'll see. So suppose these xi's are following the exponential distribution theta. They are the random sample from that, right? So the joint distribution would be just this. Okay, the product of the marginals, and then we have this. Okay, so now what is the likelihood ratio test? Likelihood ratio test is to take the ratio of two things. One thing is the maximum value. So for every fixed x, what I'm saying x here, the x is actually a vector of this x1 through xn. So for every fixed x, we want to find the maximum value of this joint distribution over the region specified by the null hypothesis. But the region specified by the null hypothesis only contains a single value, theta 0. So the maximum value of this over that region, which is only theta here, theta 0 here, is nothing but just plug in theta equals to theta 0. So that's why we have this. Just plug in theta equals to theta 0. That will be our numerator in the likelihood ratio test statistic. Okay, I simplified a little bit because this is just the n times x bar. Okay, and the denominator is a little bit tricky, so we need to find the theta that can maximize this thing for every fixed x. So we know that for every fixed x, the maximizer of this is like we're doing the likelihood ratio, maximum likelihood estimate. So we just need to look at the joint distribution, take the logarithm of it, and then take the derivative, set it to 0, solve for this theta. Okay, so now taking the derivative, taking the logarithm of this joint distribution, we'll get this. Okay, and then solve for the best theta, because we have a freedom to choose our theta from any real value. So the best theta will be just the, which is just the maximizer, which would be a critical point of this L, this log likelihood function. So take the derivative of this log likelihood function, set it to 0, then we can solve for the theta, and the theta turns out to be the sample mean. Okay, so that means the maximum value of this for a fixed x will be just this function with theta equals to theta equals to the sample mean. So that is how we get this equal to that, and when we plug in theta equals to the sample mean, we get this. So we can simplify this because this is essentially just n x bar, and they will cancel with the x bar below, and we'll just have this. So this is the denominator in the likelihood ratio. And then the ratio, as we said, the likelihood ratio function, which is just this, and that's the ratio of these two things. Then when we simplify it, it becomes that. Okay, now the likelihood ratio test is just to set a critical region in the form that this is less than equal to k. And this is less than equal to k means that this whole thing here is less than equal to k. Okay, the whole thing here is less than equal to k, and we just need to solve for, simplify it because the question asks us to extract this part only. Okay, now see here, that's the part. We now need this to be less than equal to k, so solve for this part here. We'll get this less than equal to this, which can be simplified into that. And this is our capital K here. So we can simply put our critical region in the form that once we get the random sample, we can calculate the sample mean, and we can calculate this value. Once this value is less than equal to this capital K, which is this value here, okay, then we can reject H naught. Okay, so there is a remaining issue in practice. Is that how do we really figure out this little k here or this capital K here? Remember that we need to figure out that value we need to get this value k such that the critical region has a prescribed significance level alpha. Okay, so we need to make sure to choose that particular k so that this thing here, this less than equal to k, has a probability equal to alpha. Okay, and in that case, we need to figure out the probability of this sample mean. probability distribution of the sample mean, assuming that each random sample follows the exponential distribution with theta equals to 0. That may not be easy, okay? But that is something we need to do if we're really going to do this approach.